So today we're going to talk about different kinds of angles in triangles and how we can find those angle measures. First thing we're going to talk about is the triangle sum theorem. And what this tells us is that all three angles in a triangle added together will equal 180 degrees. So all of our angles added together gives us 180. So let's look at an example. I have this angle, 3x plus 55, 2x plus 10, and up here, 100 degrees. So what the triangle sum theorem tells us is that we can add these three angles together and they will equal 180, the three angles of the triangle. So I have 3x plus 55 plus 2x plus 10, and then I'm missing that top angle of the triangle, so I don't know that yet. But hopefully we remember that vertical angles are congruent, and I have a pair at the top of the triangle. So that means that this 100-degree angle is vertical to the top angle of the triangle. So I would add 100 because that is our third angle. From there, you can just solve this as a regular equation. 5x plus 165. It's going to equal 180. So I have 5x equals 15, and we get x equals 3. So then we are done, and we solve for x. Now I want to talk about exterior angles of a triangle. So the exterior angles are formed by extending one side of the triangle, like we see right here. That side was extended, and this angle formed is an exterior angle. We extend, and you get an exterior angle. Extend, and you get exterior angle. So now the other angles that we have labeled, those are called your remote interior angles. So what's important about those is that they don't ever touch the exterior angle. So we're not ever including this angle that touches the exterior angle. That is not a remote interior. So now we're going to talk about the triangle exterior angle theorem. And what that tells us is the exterior angle is equal to the sum of the two remote interiors. So adding those two remote interior angles together. So we have the exterior equals interior plus interior, making sure that we remember they are the remote interiors. So let's look at a couple examples. Here this question mark is our exterior angle, and then we have our two remote interiors. So if you remember the exterior angle theorem, tells us the exterior is equal to the interior plus the interior. So now we know that the exterior was our question mark is equal to 77 plus 78. So that means our question mark is 155 degrees. So down here we have our exterior angle and then our two remote interiors. So following that same process, exterior equals the interior plus the interior. So our exterior was 117 is equal to question mark plus 89. So I subtract 89 from both sides and we get our question mark to equal 28 degrees. So let's look at another example. Here I want to solve for x, y, and z in this picture. So solving for x, I can use the triangle sum theorem because I have two angles and I'm solving for the third. So I know that 58 plus 46 plus x is going to equal 180 degrees. So when I combine my like terms, I get 104 plus x equals 180. Subtract, and you get x is 76 degrees. So to solve for z, we could use the exterior angle theorem. This is our exterior, and this would be an interior and an interior, remote interiors. So the exterior angle theorem will tell us that z is equal to 58 plus 46. So that means that z is equal to 104 degrees. There are other ways you could have done that. You could have used a linear pair, but that's just the using the exterior angle theorem. So now to find y, we can go back to the triangle sum, because 13 plus 104 plus y has to give us 180 degrees. So 117 plus y is equal to 180. So that means that y would equal 63. So we're good. So now we're going to talk about the parts of an isosceles triangle. So what makes an isosceles triangle isosceles is because it has two congruent sides. Those congruent sides we call the legs. So in that picture, we can see that they are congruent because they have the tick marks, which mean that they are congruent. So the one side that is not the same, that is not congruent, is called our base. So the two angles at the base, we are calling our base angles. Keep in mind those base angles in the base are not necessarily always on the bottom. They depend on where the legs are. So that third angle that is not congruent is called the vertex angle. And those are the parts of an isosceles triangle. So now we're going to talk about the converse of the base angles theorem, and that just reverses what we just talked about. Where before we started knowing that the legs were congruent, we could conclude the angles. But now we know the angles and can conclude the legs. So, angle C is marked off as congruent. The only side that angle C does not touch is AB, so that means that that's going to be a congruent leg. Angle B, the only side that angle B doesn't touch is AC, so that will be the other congruent leg. So be careful, because your base angles don't always have to be on the bottom. As you see here, AC and AB are your legs, so that means that BC is your base. And angle C and angle B are your base angles, and they're not on the bottom, so just be careful. That is a mistake that I see often. Now we're going to talk about a perpendicular bisector. Perpendicular bisector is a line, segment, or ray that is perpendicular to a segment at its midpoint. So that means right here we would have a midpoint. And we see that because of our congruent tick marks. So we know that segment EG was cut in half, and then we also know that it is perpendicular because of the right angle symbol. Now we're going to talk about a theorem, and this says if a line bisects the vertex angle of an isosceles triangle, then the line is the perpendicular bisector of the base. So here on the left-hand side, angle C is your vertex angle. And we see that it is bisected by CD because we have those two congruent arcs. So we have the beginning part of a line segment bisects the vertex angle of an isosceles triangle. So we have the beginning part. From that, we can then conclude that that line, CD, is a perpendicular bisector. So that means that CD is going to be perpendicular to the base, which we see right there with that right angle symbol, and it also splits the base in half. And we see that with those two congruent tick marks. So let's look at an example where we're going to find angles. So here, this is the only angle that I have, that 23 degrees. So this right here is a leg. The only angle that that leg does not touch, or the one directly across from it, would be down here. So that's going to be a base angle. This was our other leg. The only angle that this one does not touch, or directly across from it, is where the 23 is. So that means that those two base angles are congruent. So this angle is 23 degrees. Now to find the top angle, we know that the triangle sum is 180, so 23 plus 23 plus the angle that we're still looking for has to give us 180 degrees. So that means that our question mark angle will be 134 degrees. So now let's switch those places around. Once again, here's our leg, congruent base angle. Other leg, congruent base angle. Now our 23 is up here. We don't know either of those angles, but we do know that they both have to be the same. So we could call them both x because they have to be the same. So that means that 2x plus 23 has to give us 180. So you get 2x is equal to 157. And x is going to equal 78.5. Okay, so in this picture we're looking for x and y. We have a line segment that bisects the vertex angle. So that means that this line segment is going to be the perpendicular bisector of the base. So then, right then, we know that x is 90. And it would be like that on both sides. So looking at the right-hand side, I have 90 degrees, 46 degrees. This is not y, but I can find it. So 90 plus 46 plus question mark has to give us 180 degrees. 136 plus question mark has to give us 180. So our question mark is 44 degrees. And since both of those angles up at the top were bisected, that means they're the same. So y is 44 degrees. And the last thing I want to talk to you about is equilateral triangles and what we know about them. So you know in equilateral triangle that all of the angles are the same, they're all congruent, and all of your sides are the same. So if you only know one, then you can conclude the other. If you know all the angles are the same, then that means all the sides are the same. If you know all the sides are the same, then that means all the angles have to be the same. So just to make sure that we know, if we have 3 of the angles that are the same in a triangle, as an equilateral triangle, every angle is always going to be 60 degrees.